Have you ever tried to carry like 10 loose items in your hands instead of just using a backpack?
Oh, absolutely. You know the feeling.
Right. You've got your car keys dangling from your pinky finger.
A hot coffee just like balanced perilously on your wrist.
Yes. Your laptop is tucked under one arm. You've got a stack of mail threatening to slide right onto the pavement.
And you are just praying, literally praying, that you don't encounter a closed door.
Exactly.
Yeah.
It is stressful, it's highly inefficient, and, well, if you trip, absolutely everything is going flying across the asphalt.
We always convince ourselves we can manage just one more thing.
Oh, just one more thing. Yeah.
Right, then another. And before we know it, we are completely immobilized by the sheer number of, individual disparate items we're trying to juggle simultaneously.
Too much.
The cognitive load of simply holding the items overrides our ability to actually walk to our destination.
Today, we are taking a deep dive into exactly that scenario, but we are looking at it in the digital realm.
Which is fascinating.
Yeah, it really is. We have a real-world, incredibly intimate glimpse into a software developer's thought process today.
Yeah, we're unpacking a newly published journal entry.
Right, dated today, May 4th, 2026.
It's titled Notes on Haskell Programming, Part 126, by a developer named Ang.
And I think that number is important, Part 126.
It is. It tells us we are dropping into the middle of a marathon.
Yeah.
This developer has been building, maintaining, and refining this system for a very long time.
So we aren't looking at theoretical textbook examples of code.
Not at all. We are looking at a living, breathing project that has likely accumulated, its fair share of technical debt and organic complexity over time.
Right. So our mission for this deep dive is to explore the art of refactoring.
The messy reality of it.
Yeah. We're looking at how developers clean up their own messes, the absolute relief of streamlining a complex system, and, well, the somewhat cruel reality that every new solution usually introduces a brand new architectural challenge.
It never really ends.
Never. Okay, so let's unpack this. Before we can appreciate the structural solution Ang implements, we have to understand the exact pain point that sparked this whole journey.
The catalyst.
Exactly. Ang starts the entry by confessing that they have been passing arguments from this args data type as individual parameters to various functions.
Just handing them over one by one.
Yeah, and Ang explicitly states this approach is getting a bit tedious.
And, tedious is a heavy word in software engineering.
Is it?
Oh, yeah. It implies a drain on developer momentum. Let's trace how a code base actually arrives at that point of tedium, though.
Okay.
You write a function, right? And it requires two parameters. It takes an input path and an output format. It's clean, it's fast, you move on.
Makes sense.
But then months later, you realize that function also needs to know if debug mode is active.
So you just toss it in there.
Right. You tack on a third parameter. Then a week later, it needs a verbosity level. You tack on a fourth. The developer mind is so focused on solving the immediate feature request, not the creeping architectural rot that's happening.
It's the carrying loose items problem all over again.
Yes.
Like if I go to a coffee shop, I don't hand the barista a handful of loose coffee beans, a cup of water, and a paper cup separately, and say, assemble this.
That would be insane.
I just ask for a coffee.
Yeah.
Handing over individual components every single time you want an action performed is just exhausting.
It really is.
But wait, let me push back on this a little bit.
Sure.
Isn't handing over individual items incredibly explicit? Like, the function demands exactly 3 specific things, and you hand over exactly those 3 things.
That's true.
There is no mystery about what data is being used by that piece of code. It kind of forces you to be hyper-aware of the data flow, doesn't it?
You're not wrong. Explicit parameter passing does create a very transparent data contract. You look at the function call, and you see all the moving parts right there.
Right.
The problem, the real problem is rigidity.
Rigidity.
Yeah. When a function requires 5, 6, or 7 separate parameters, it locks your entire architecture in place. Knowledge and data are most valuable when they can be routed and applied efficiently.
Okay.
Ang's realization here, spotting that this explicitness has crossed the line into tedium, is a perfect example of catching a compounding inefficiency.
Because it's just going to get worse.
Exactly. Every time you want to add a new capability to that function, you are forced to go back and manually update every single place in your sprawling code base where you previously handed over those individual items.
Oh, wow. So if you use that function 50 times.
You have to update 50 lines of code. The system becomes brittle, not because it's broken, but because it is too exhausting to change.
Okay, yeah, that sounds like a nightmare. So Aang recognizes this maintenance nightmare and decides it's time to build a backpack.
A much-needed backpack.
We move to the first actionable step, creating a centralized location for the data. Aang extracts the arg's data type and moves it into a common shared module.
Right, the XS2 ebook types module.
Yes, xs2ebook.types.
And by doing that, they export both the data type and its associated fields.
Which means what, exactly?
It makes the internal structure of that data universally accessible to any other part of the application that imports that module.
Okay, so everyone has access to the backpack. The text actually gives us the exact contents of this newly isolated args record.
Let's hear it.
It contains input path, which is a file path output format, which is an export format, verbosity, which is an int data mode of the bool, and open after, also a bool.
That's quite the list.
Right. And here's where it gets really interesting. Looking at these fields, you can practically see the software skeleton.
You really can.
Input paths, export formats, an option to open the file after processing. I mean, it is clearly an ebook converter. We are looking at the core configuration state for a command line tool.
What's fascinating here is how the data structures of a well-architected program tell the complete story of its intent.
Yeah.
You don't even need to read the execution logic or the complex algorithms. By examining the nouns of the system, the args record, you can accurately deduce what the verbs are going to do.
The state dictates the behavior.
Exactly.
It's like looking at someone's packed luggage and knowing their vacation destination.
Oh, that's a great way to put it.
Right. You packed a swimsuit, sunscreen, and a beach towel. You're obviously going to the beach.
You packed an input path and an export format. You're converting a document.
Exactly. Now, the source notes that this new record also derives show in eek.
Which is pretty standard.
Yeah, standard to slap those on a configuration record. But it highlights that Aang isn't just storing data. They're preparing it to be logged out for that debug mode, and they're ensuring different configuration states can be compared against each other for equality.
And if we connect this to the bigger picture, creating a dedicated shared module like XS2 ebook, types is a fundamental strategy for preserving sanity in large applications.
Also,
Well, consider a massive public library. If every citizen kept their reference books in their own private living rooms, finding and sharing knowledge would require navigating a chaotic maze.
right, you'd be knocking on individual doors, asking for permissions just to read a book.
Exactly. By moving args to XS2 ebook, types, Aang is constructing the public library.
I like that.
They establish a single source of truth. Any module that needs to understand the shape of the application's arguments simply visits the library.
It completely decouples the definition of the data from the location where the data happens to be used.
Precisely.
So Aang identified the pain point, the tedious juggling of loose configuration settings. They built the backpack, this beautifully structured args record, residing securely in the public library of the types module.
And now we get to see the actual payoff of this refactoring.
Yes. Aang applies this centralized backpack to a specific heavy-lifting helper function called convert-to-ebook.
Which lives inside the xs2ebook.cli.hs module. This is the moment the theoretical architecture meets practical execution. We shift focus from the static shape of the data to the dynamic behavior of the program.
Aang actually provides the code diff in the journal entry, showing the before and after.
Always helpful to see the diff.
Oh, it really is.
Previously, convert to ebook took all those loose items. Listen to the structure of this old type signature.
Yeah.
It took an export format, an arrow, a file path, another arrow, a list of token, an arrow, and finally culminated in an I/O of either pandohair.
Okay, let's break that down because let's visualize what those arrows actually represent in a Haskell pipeline.
They can look like alphabet soup if you aren't used to it.
They really can, but
Yeah.
they denote a sequence of strict demands. The function swallows the format, then it pauses and demands the file path.
Right.
Once satisfied, it reaches out and demands the tokens. It's like a conveyor belt that refuses to move until you place each specific loose item onto it in the exact prescribed order. And let's talk about that list of token parameter for a second. The text doesn't spell it out explicitly, but given that this is an ebook converter interacting with Panda,
A very popular document converter, yeah.
right, those tokens represent the parsed, chunked pieces of the original document. The text blocks, the formatting tags, the structural headers.
Meat of the document.
Yes. It is the raw material that the function is going to mutate.
It's the payload. And then we arrive at the end of that arrow pipeline, the output signature.
The I/O. either Pandocare.
Yes. This is a profoundly expressive detail. The I/O wrapper is a massive red flag in Haskell.
All red flag. In a bad way.
Not bad, just a warning. It signals that we are leaving the pure, predictable world of mathematical functions and touching the messy, unpredictable outside world.
Ah, right. The function is going to interact with the file system, write to a disk, or trigger an external process.
Exactly, and the either Pandocare part is equally expressive. It's telling us that when this function ventures into that messy external world, it guarantees one of two outcomes.
It's an either-or situation.
Precisely. It will either bring back a specific, structured failure, a Pandocare, or it will bring back absolutely nothing, represented by those empty parentheses.
And in this context, nothing means silent, total success.
Yep. It did the job, and there is no further data to report.
That is so clean.
The type signature enforces an honest contract. The compiler will literally refuse to build the program unless the developer writes code to handle the possibility of that Pandocare.
It forces you to acknowledge that the real world is prone to failure.
Exactly.
Okay, so that was the old tedious pipeline.
Yeah.
Now look at the streamline type signature ang implements.
Let's hear it.
Args, an arrow, a list of token, an arrow, and that same I/O, either Pandocare or output.
That is significantly shorter.
Right. So what does this all mean? It means ang has entirely stabilized the function's interface.
Yes.
If they decide tomorrow that the converter needs a new parameter, maybe a custom font setting or something, they add it to the args record in the library. They don't have to touch the convert ebook signature at all.
The interface remains pristine. The function simply says, hand me the backpack.
Hand me the backpack.
Right. It doesn't care if you've added 3 new pockets or a specialized compartment to that backpack over in the types module. The fundamental demand, the signature, remains stable, which stops the ripple effect of changes dead in its tracks.
Okay, but let me play devil's advocate again.
Go for it.
Doesn't bundling all this together mean the function is suddenly carrying around a massive amount of data it doesn't actually need? Let's look back at the fields in that args record. The deep in the weeds convert the ebook function probably doesn't care what the application's overall verbosity level is set to.
Sure.
It certainly doesn't care if the user wants to open after the conversion is done.
No.
We are handing it a massive Expedition backpack when it literally only needs the sunglasses and the map.
You've swapped parameter tedium for data bloat.
Exactly. Is that really better?
Well, you've zeroed in on one of the perennial compromises in software design. Yes, the function is receiving the entire configuration payload, including peripheral flags it will never inspect.
So it's impure, in a way.
From a standpoint of theoretical purity, yeah, it is oversupplied. The function has access to information outside its strictly required domain. But the massive counterweight to that impurity is maintainability.
Which is what ang was after from the start.
Exactly. Ang explicitly writes in the journal, and I quote, "This is much cleaner because we won't have to keep changing the function call every time we add a new field to the args data type."
Because the developer's time is the most expensive resource in the equation.
Without a doubt. The computational cost of passing a slightly larger record in a modern compiled language is, negligible.
Barely registers.
Right. But the human cost of a developer manually hunting down and updating 50 different function calls across 20 different files just to add a single configuration flag. That cost is enormous. It causes fatigue, it introduces typos, and frankly, it breeds resentment toward the code base.
Nobody wants to work on a code base like that.
Nobody. So Ang is making a highly calculated, pragmatic trade-off. They are sacrificing a microscopic sliver of scope purity to buy a massive insurance policy against future architectural friction.
So we've solved the tedious parameter passing, we've constructed the centralized library, we've locked down a stable, future-proof function signature.
It sounds perfect.
It looks like a complete refactoring victory. But this is software development.
Oh, there's always a catch.
Solving one bottleneck almost always acts as a magnifying glass, revealing the next critical flaw in the system.
Refactoring is basically an archaeological dig. You brush away the top layer of dirt only to find a much denser layer of rock underneath.
A denser layer of rock. I love that. And the source material gets incredibly specific about this new layer of rock.
Let's dig into it.
To make the new function actually execute, to reach into that supplied backpack and extract the specific map and sunglasses it needs, Ang utilizes pattern matching.
Oh.
The implementation code reads, convert to ebook open parenthesis, args path fmt, close parenthesis, space, tokens.
Ah.
Let's look at the syntax inside those parentheses. Args, space, path, space, FMT, space, underscore, space, underscore, space, underscore.
Those underscores.
Those three underscores are placeholders.
Right. The function is interrogating the structure of the incoming data. It sees the args record. It binds the first item it encounters to the variable path.
Yeah.
It binds the second item it encounters to the variable FMT. And the underscores, they represent a deliberate discarding of data.
So it's just ignoring them.
Exactly. The function is basically declaring, I acknowledge there are third, fourth, and fifth items here, but I will not be assigning them to memory.
Okay, but wait. If I go back to that centralized library module and update the R's data type, let's say I insert a brand new author name field right between path and output format.
Oh boy.
This entire function collapses, doesn't it? The underscores and variables are operating entirely lined. They don't know what data they are grabbing. They only know where they are reaching.
This raises an important question about the hidden fragility of systems. Ang documents this exact danger, writing, while this works, pattern matching every field by its position is still pretty brittle. If we add another field to the record later, this code will break again.
Brittle. That's the perfect word for it.
We're looking at the fundamental difference between relying on the location of an asset versus relying on the identity of an asset.
It's like the difference between a strict seating chart at a wedding and giving everyone a personalized name tag.
That's a great analogy.
With a strict seating chart, the caterer just brings the vegan meal to whoever is sitting in chair number 2. They don't check names.
Positional pattern matching is that strict seating chart. The function assumes the data in the second slot is always the export format.
So if you casually update the args record and slide an author's name into slot number 2, the whole seating chart shifts. The function, completely unaware of the change, grabs the author's name, attempts to use it as a file format to run a pandoc conversion, and the entire application violently crashes.
It's a disaster.
You've hidden the loose items inside a backpack, but inside that backpack, the items are just floating in a highly volatile, completely unlabeled sequence.
Ang successfully mitigated the external interface problem. The function's signature is beautiful and stable.
But they traded it for an internal implementation problem.
Exactly. The mechanics inside the function are brittle, and this is the reality of the refactoring cycle. You alleviate the most immediate, agonizing pain point in this case, the tedium which finally gives you the mental bandwidth to identify the structural weaknesses you couldn't see before.
To recap Ang's journey in Part 126, we started with the friction of passing individual parameters, dropping loose items everywhere. Ang centralized the state into the args record, creating a public library in the types module. That architecture allowed them to streamline the convert-to-ebook function pipeline, passing a single, unified configuration instead of a chaotic list of demands.
A huge improvement.
It was.
Whoa.
But that elegant pipeline dumped us straight into the perilous reality of brittle, positional pattern matching with a row of fragile underscores.
It is a perfect microcosm of software engineering. Every solution is just a bridge to a more sophisticated problem.
A more sophisticated problem. I like that. And Ang's final sign-off for this entry is a total cliffhanger.
Oh, yeah.
They write, but I'll dive into how to handle that more flexible in future post. Till the next post, yours truly, Ang.
They know it's a trap.
They are fully aware the seating chart is a ticking time bomb, and they're already designing the next architectural evolution. We'll have to wait for Part 127 to see how they abandon that positional setup.
One would assume the next iteration involves record syntax. You know, accessing fields explicitly by their declared names rather than their arbitrary index.
Right, checking the name tags instead of the chair numbers.
Exactly. But that requires a different set of trade-offs we'll have to analyze when they publish it.
Well, before we wrap up, I want to leave you, the listener, with a thought that translates this concept of brittleness out of the code base and into your daily life.
It's universally applicable.
It really is. We just dissected how a system can silently become incredibly fragile simply because it relies strictly on the sequence of events rather than the identity of the inputs.
Just waiting to break.
Think about your own daily routines, your household logistics, or the collaborative systems you rely on at work. Where are you currently relying on a brittle positional seating chart?
Where is your ticking time bomb?
Exactly. Where do you have a workflow or communication chain where if just one single step happens slightly out of order, or one unexpected new variable is dropped into the mix, the entire process completely stalls or breaks down?
We all build these rigid pipelines to cope with our own versions of daily tedium. Identifying them before they crash is the hard part.
It really is. You might think you've optimized your life by finally shoving all your loose tasks into one central system. But if that system requires you to execute every single step in a hyper-specific, unchangeable order just to get through the day, you might just be setting yourself up for a much larger, much messier failure.
Something to think about.
Definitely. Thank you so much for joining us on this deep dive. Keep examining the architecture of your own systems, and we will see you next time.